of Meteorology has declared a third consecutive La Nina.
Visualizations of the Earth and the climate system to tell a story that may not be all that pretty for next winter's rainfall.
As human-caused climate change alters weather patterns around the planet, one overarching question is gaining scientific attention. How will it affect one of the world's most powerful weather makers? Climate change is increasing the frequency of extreme El Nino events, which is causing droughts to deteriorate, floods to worsen, and storm patterns to shift. What is the latest scientific warning, and how will it affect our world? Stay with us until the very end to learn everything there is to know about the most recent announcement made by scientists. When debating climate change, the discussion frequently focuses on future developments. However, it is apparent that the climate is already changing. Weather patterns have changed dramatically in recent decades, which many people attribute to climate change. However, experts disagree that these changes are the result of climate change. Australia is one of the major countries that is directly in the path of these erratic weather patterns. For the past few years, the country has been severely impacted by the legendary La Nina winds, which have resulted in catastrophic flooding and cooler summers on the country's east coast. Let's break down the La Nina weather phenomenon for those of us unfamiliar with it. La Nina is a natural climate cycle that pushes chilly air across the tropical Pacific Ocean. It is one component of a broader cycle, the other being El Nino, which produces much warmer winds than La Nina. Both meteorological phenomenon have opposing effects on the central and eastern tropical Pacific, with sea surface temperatures fluctuating between the two. The El Nino-Southern Oscillation, or ENSO, refers to both meteorological events. The shifting effects of La Nina and El Nino have massive effects on weather patterns, delivering catastrophic tropical rains and floods to one location while causing droughts in others when the cycle shifts. Although the climatic effects and repercussions of ENSO are mostly felt in the tropical Pacific, these effects can spread to any portion of the globe, making ENSO the dominant driver driving global interannual climate variability. ENSO's effects on precipitation and temperature change are most notable in East and Southern Africa, Southeast Asia, the Western Americas, Australia, and Antarctica. Australia has had more La Nina occurrences in recent years than any other location, and the most recent floods was caused by the third La Nina event in a row. 3 La Nina episodes in a row are extremely rare because these events typically alternate annually, with warmer El Nino events expected to follow a single La Nina. Some researchers attribute it to rising surface temperatures, which have variable effects on the frequency and intensity of these climatic phenomena. However, other scientists and academics have emphasized that while 3 consecutive La Nina occurrences are rare, they are not impossible or unheard of. There has been a documented run of La Nina occurrences that occurred between 1974 and 1976, as well as 1998 and 2001. The Nina sends colder winds from the eastern and central Pacific, which blow into regions of eastern Australia, accounting for the country's wet and cold conditions over the last 2 years. El Nino occurrences, on the other hand, have caused severe drought and dry weather in the southwest United States and Latin America. According to the National Bureau of Meteorology, the forecast third La Nina episode would be weaker and shorter-lived than the first 2. Although this will be good news in terms of rainfall intensity, it will be bad news for those in East Australia who have only recently recovered from the recent heavy rains and flooding. The last 2 La Nina periods brought heavy rains, filling reservoirs and causing salt and soils to dry out. These estimates were poor news for inhabitants in affected areas in East Australia, such as Queensland and New South Wales, which are still struggling to recover from the previous season's severe flooding. However, the main question remains as to what these phenomena have to do with climate change and whether or not greenhouse gas emissions increase the intensity of ENSO events. Experts researching the many implications of ENSO events like La Nina and El Nino have indicated that it is still uncertain how these occurrences would be altered when the planet's surface temperature rises. However, there is some evidence that climate change may have an impact on the frequency and duration of these ENSO episodes. Earlier this year, a research report on the links between events like La Nina and regional climates in the strongly affected Pacific countries like Australia was published. According to the report, an increase in surface temperatures caused by greenhouse gas emissions could exacerbate the frequency of ENSO effects in most sections of the country. Experts discovered that there were more climatic elements at work that govern the intensity and frequency of both rainfall and drought in Australia after examining the effects of La Nina occurrences in recent years. These two pressures, as well as naturally occurring climatic influences such as the Indian Ocean Dipole's southern annular phase. The Indian Ocean Dipole is characterized by an oscillation of varying sea surface temperatures, with the western Indian Ocean becoming comparatively warmer while the eastern Indian Ocean gets irregularly cooler. This rotation of warm and cool sea surface temperatures is associated with increased rainfall in cooler areas of the ocean and droughts in warmer portions of the ocean. The southern annular mode, on the other hand, is a low-frequency mode in which atmospheric variability produces pressure fluctuations and the movement of intense westerly winds that surround Antarctica. These winds are located in the lower southern hemisphere and have a significant impact on weather systems and winds in countries such as Australia. These two unique climatic conditions, along with La Nina, make a relatively hot and dry Western Australia cooler and more prone to severe rainfall, as we've seen in recent years. All three climate elements have previously been prevalent, with the previously known instance occurring in the spring of 2010 when Eastern Australia witnessed a similarly high rainfall record. Although the 2010 phenomena were a one-time occurrence, it indicates that the present tendency of La Nina events may cause greater rainfall in the following sea season, resulting in further floods. Although estimates suggest that another La Nina event is possible, it is unclear which portions of Australia may be affected. The combination of La Nina events, the southern annular mode, and the negative Indian Ocean dipole will almost probably mean bad news for several portions of the country. However, the effects of these climatic elements are not all bad news for Australians, as milder global temperatures and regular rainfall imply that droughts will be reduced significantly. In reality, some of Australia's worst droughts on record have been caused by a lack of La Nina and negative Indian Ocean dipole conditions in recent years. With 2 consecutive La Nina periods in eastern Australia, the region is unlikely to endure catastrophic droughts in the foreseeable future. La Nina's chilly wet impacts on the region minimise the likelihood of major bushfires, which have ravaged many parts of Australia in recent years. Mother Nature, on the other hand, will not be ignored, since while more rain means fewer dry plants for bushfires, it also means more green plants that will multiply or dry out in the future. This could provide additional fuel for fires in the future if dry, hot conditions return with the warmer El Nino season. However, one significant benefit of La Nina is that the cooler and wet conditions it brings usually reduce the global mean temperature by cooling a large area of the Pacific Ocean, which happens to be one of the world's warmest regions of sea surface temperatures. However, this global cooling effect is usually transient, and continued greenhouse gas emissions tend to boost the temperature back up, especially when the warmer El Nino event occurs. Many Australians have been wondering if the current trend of La Nina events could lead to a 4th consecutive La Nina, but experts feel there is no cause to be concerned. This is based on the fact that, as rare as a triple La Nina event may be, it has occurred in the past, but there is no record of a quadruple La Nina event in history. Experts have warned that for the time being, we must deal with the current La Nina occurrences while also mentally preparing for the rare situation of Australia experiencing yet another season of freezing temperatures and consistent rains. The consequences of ENSO occurrences have been linked to the effects of climate change and rising global temperatures, but the key worry is how these effects will reflect future changes. But before we draw any judgments about how and when an ENSO event may affect global climatic weather conditions in the future, we must consider how these events have played out in the past. We must comprehend whether or not occurrences are changing as a result of greenhouse gas emissions. According to climatology specialists, ENSO has changed but has also remained constant. This may appear to be paradoxical, but stick with us. According to expert data, the amplitude and frequency of ENSO occurrences have both increased slightly since the 1950s. This growth contrasts with the occurrence of ENSO occurrences between 1850 and 1950, and even as far back as the 15th century. According to research published by Intergovernmental Panel on Climate Change, the increased number of intensity of El Nino events in the previous 20 to 30 years could be attributed to rising temperature levels in the Central Pacific. However, while the paper mentions a link between temperature and ENSO event changes, it is obvious that this does not necessarily imply that human-caused climate change is to blame. Using the instrumental record and paleoclimatic proxy evidence, scientists were able to trace the incidence of ENSO events back thousands of years. These paleoclimatic proxy records are a data source that show us the Earth's climatic state during a specific time period in the past. These records are derived from the formation and evolution of ice cores, tree rings, and sediment deposits in lakes and seas. A review of these records reveals that throughout the last 11,000 years, ENSO occurrences have changed in terms of frequency and amplitude. This tells scientists that there is no clear proof that the changes in ENSO events witnessed since the 1950s are unusual or caused by climate change. Furthermore, climate model simulations have revealed similar oscillations in attempts to anticipate the patterns of future ENSO episodes. These simulations included and removed the effects of greenhouse gas emissions, with varied results in terms of future state events or events on the planet's climate. Furthermore, a careful examination of recent trends in ENSO occurrences in the Central Pacific has revealed that any variations in frequency and intensity of these events may be within the usual range of natural variability. This appears to be how the Earth operates, with unpredictable patterns of highs and lows that may or may not be directly tied to the effects of human activity and greenhouse gas emissions. According to an IPCC analysis, there is no agreement on how sea surface temperatures will change in the coming centuries as a result of greenhouse gas emissions. However, one thing is certain: the variability of rainfall across the east-central tropical Pacific is quite likely to grow dramatically during the next several years. It is also crucial to note that climate models do not predict that there will be no changes in ENSO events during the coming century. Let's hear your thoughts about these events in the comments down below.